Now, without further ado, I would like to introduce our first talk today, and presented by two of my dear friends at Alluxio, Bin Fan and Lu Qiu. You've probably heard from Lu and Bin before. Lu has been involved in open source software for many years and is currently a software engineer at Alluxio. She develops easier way for Alluxio integration in the public cloud environment. Lu is mainly responsible for leader ejection, journal management, matrix management, and big data preparation for machine learning workloads. She has received an MS degree from George Washington University in data science. Bin Fan, many of you have also seen him on our Slack or other community channels, is a founding engineer and VP of open source at Alluxio, and he is the co-chair of this event. Prior to Alluxio, he worked for Google to build the next generation storage infrastructure. And Bin has received his PhD in computer science from Carnegie Mellon University on design and implementation of distributed system. Now, on our last Alluxio Day back in April, 2 months ago, Bin and Lu has given our audience a sneak peek on the work that we've done in AI and machine learning. Now, in the past few months, we have been working diligently on this, and then the two of them today will provide a more general and deeper look at the work that we've developed in the since the last time. Bin will join you towards the later end of the talk to join the Q&A session. So let's hear from Lu first on Alluxio for machine learning workloads. Lu, go ahead and take it away.
Hey everybody, and thanks Jasmine for introducing me. And today I will give a talk about how to deploy Alluxio in the cloud for machine learning. And I think from the previous talk, many people showed to us that, okay, I'm interested in putting Alluxio in our machine learning workloads, but I don't know how to deploy it. Is it complicated? How can I configure it? How can I install it? How can I use it? There are many questions flow from our community. That's why we want to give this talk to give people the idea of how to actually deploy it. So for today's agenda, I will quickly go through what is Alluxio POSIX API, and I'm mainly focusing in how to deploy Alluxio in Kubernetes environment for machine learning workloads. And I will give some recent updates on our recent Alluxio POSIX development from the community. First, what is Alluxio POSIX API? So as you guys may know that Alluxio can connect to different remote storage and is able to catch the data from the remote storage locally and closer to your compute frameworks. And through Alluxio FUSE, we go one step further. You are able to access data in different remote storage, just like your local folder. And by using Alluxio's caching ability, you can even use those data just like your local data. And so it provides many benefits for many of the machine learning frameworks like TensorFlow, PyTorch, Caffe, because those frameworks, they are built on top directly with your local dataset. They actually may not be able to bundle to other storage systems, or it's hard for you to bundle to those storage systems. And by using Alluxio, you can directly connect those frameworks to those storage systems, and without need to like, oh, how can I modify my script, etc. And if you can see this folder, this graph here is that after you mount different storage system to Alluxio namespace, and then you can mount the whole Alluxio namespace as a local folder. So when you open this folder, it just looks like your local directory and have your local data. But actually, those folders, they may represent different remote storage. They may represent an HDFS cluster, they may represent an object storage. And those data, they are actually local data, which already cached by Alluxio, or they may be actually are still reside in your remote storage. When you run the training job, we will fetch those data for you. Another benefit provided by Alluxio POSIX API is that instead of catching the whole data set, copy all the whole data set to each of the machine that running your training job, Alluxio help you to divide the big data set in multiple pieces, in multiple blocks, and store those blocks onto different Alluxio servers. So for when you're running a chaining job, the data maybe reside in your local node, or the data maybe reside in the nearby worker nodes. It's pretty close, much closer than you need to reach out to your remote storage to fetch those data. And if one server crash, there are still other servers able to serve your request. So you don't need to worry about, okay, if I copy the whole data set into one of my disks and the disk crash, what should I do? Do I need to wait for another day to copy the data again? So you don't need to worry about those things. And now we jump to our favorite topic about how to deploy Alluxio in Kubernetes for machine learning workloads. So it's really interesting to see that we actually didn't recommend to our users that you should deploy Alluxio in Kubernetes environment for machine learning. But all our users, especially those users that use Alluxio in production environment in their machine learning training, they deploy Alluxio through Kubernetes. So that must be a reason behind. So I think the main reason for that is that by using the cloud, by using the Kubernetes, you can really easily to provision a cluster and deploy your services. And also you can really easily to run a distributed training job through Kubernetes, like the Kubeflow or Arena. And you can use one click to run all the different distributed training on the cloud. And by using the same framework, we can also deploy Alluxio services in the. So the first step is that you can launch a cloud cluster, the Kubernetes cluster in the cloud. And then you can deploy the Alluxio services through a really quick way through Kubernetes. And the Alluxio services will be co-located with your training jobs. Alluxio services will be connecting to your desired storage. If you want to load the data into the cluster, Alluxio can help you to load your desired data set. And then you can launch your training job with providing the data, the local folder, the mom-pom that provided by Alluxio to help you to access your data in the remote storage, all the data that already became cached in Alluxio. So that's the steps: provision the cluster, and then deploy Alluxio through Kubernetes, and then launch the distributed training job via Kubeflow. And then you can enjoy the training speed acceleration by catching data locally. Users who want to run the machine learning training can focus on their training logics instead of worry about how can I prepare the data, how can I connect to the remote storage or copy the data to the cluster. You only need to focusing on the training logics. Now I'm going to talk about how can we actually deploy it in the Kubernetes environment. And actually there are 4 ways that we can deploy it. I don't want to introduce that many ways. But there is no a single way that already dominant in the Kubernetes world. I really hope so. So those ways are usually used by our community users. And some of the ways that actually are introduced to us by them. And they said that, oh, we prefer this way, we use this way in production environment. So I will introduce all this to you. But all these ways, they do the same thing, is like deploy Alluxio in the cluster. They may have some small variants of what they are actually good for. So the default way, which is the most basic way, is actually using the kubectl to launch Alluxio cluster in Kubernetes. It's usually using in some testing environment instead of the production environment, especially when your deployment is really simple. You only have several really short YAML files to deploy your service. And it also is useful when your requirement, you have some special requirement, which is not fulfilled by other deployment ways so far, then maybe you should go for the kubectl way. And another way that introduced by our official documentation is the Helm. Helm is the package manager for Kubernetes. It's preferred over kubectl. And Alluxio have its shared Helm charts. So instead of providing all the YAML scripts and trying to find which part I need to modify on top of the YAML scripts, you can use our shared Helm charts and provide your desired modification aside from the defaults. And the Alluxio service can be deployed in one command through the whole cluster. It's also really helpful if you want to deploy Alluxio not in a single cluster. Maybe you use it for your online machine learning long-running servers, and you also want to run it for some testing or some experiments. So you want to deploy Alluxio through multiple different environments and multiple clusters. In this way, it's good for you to create a common template for Alluxio services and deploy Alluxio services through multiple environments without copy pasting. And kubectl and Helm is actually the official ways that given out by our deploy Alluxio on Kubernetes official documentation. So feel free to check out the link here. Now I want to introduce two other ways, maybe not that commonly used, but it's actually really helpful in the production environment. So the one way is Alluxio CSI. CSI is called the Container Storage Interface. So it allows us to expose Alluxio as a persistent storage to the container applications like Docker, Mesos, Kubernetes. And by using Alluxio CSI, we don't need to implement a Kubernetes driver and put it into the Kubernetes package and waiting for their releases. We can develop the features that we want and release it. So from the Microsoft production use case, they actually use Alluxio CSI because it's easier for them to have some mount-point level access control. They want to have multiple mount-point for different use cases, and they may have one mount-point that is configured and is optimized for their read path by enabling some of the metadata caching. And they may want to use a wholly different configuration set for another mount-point that they want to optimize for the right path. So they can have different configuration for different mount-points. And they also can define that, okay, one team you can only access one mount-point, and the other team you can only access another mount-point. So they are able to achieve mount-point level access control through Alluxio CSI. If you are interested in knowing more about Alluxio CSI and how Microsoft actually using it in their production environment, feel free to check out the previous Alluxio Day talk about how to speed up large-scale machine learning and deep learning job with Alluxio CSI. And there are also some links about the GitHub repo about our recent improvements. I really want to thank Bin Yang from Microsoft and Baolong from Tencent for developing the CSI. Now I'm going to talk about another variance, that's the FUSE. And FUSE, they have a really complicated description. So basically, FUSE is a wrapper around Alluxio. In the previous several ways, you still need to know that, okay, how do I need to configure Alluxio on Kubernetes? How do I want to deploy it? What workloads should be mounted? And all those stuff, you still need to take care of them. But FUSE is a wrapper around Alluxio. It helps you to manage all those things for you. What you need to do is that you need to define, okay, which data set I want to use and which local folder I want this data set to be available. And by using this way, the users, they can have access control on the data set levels. So we can define that, okay, some users you can access data set A, some users you can access data set B. And all the logics behind, like how to configure Alluxio, how to install Alluxio, how to auto-scaling Alluxio, all those logics are taken care by FUSE. So it's a really good tool for you to try out Alluxio in your maybe testing environment. And after you enter production, you may want to make some modification and go to more advanced deployment ways. So just like showing in this graph, Alluxio is used as a cache runtime engine. And besides Alluxio, FUSE helps us to manage the data set, the volumes, the runtime, the cache, and the prefetch logics. All those things are taken care by FUSE. If you want to know more about why we need to develop FUSE and how it actually being used in production environment, feel free to check out the previous links about when Alluxio meet Kubernetes, why we create FUSE, and how to speed up the learning platform with Alluxio plus FUSE. And really thanks Chaoyang from Alibaba for developing FUSE. Okay, now we move to the next session about what's our updates in the Alluxio POSIX deployments. So as we mentioned before, that Alluxio deployment, especially when Alluxio entered the machine learning world, is not a single company or single person effort. It's a community-driven collaborations. And community contributors from Nanjing University, Alibaba, Tencent, Microsoft, and Alluxio both have a huge contribution to this project. And it's already in use by Microsoft, Analytics Aspects, and Boss. And we really want to make the Alluxio into machine learning world, this solution to be more mature, and we want to collaborate the efforts from other users. So in Alluxio 2.6.0, we have many of the Alluxio JNI FUSE enhancement. We improve the performance by eliminating the local RPC. We made it easier for other people to use by modularize the JNI FUSE library. We implement more FUSE operations to take care of not just the common read-write path, but also take care of many of the other Linux commands to make Alluxio FUSE more close to the POSIX standard. Also, we fixed out the issues that we found when we are actually running machine learning workloads using JNI FUSE. And also we add some matches so that we can better monitoring the JNI FUSE. So the enhancement is not stopping at 2.6. We still have many of the ongoing projects. And given by the Microsoft, we are continuing improving the CSI integration and adding more features to make it more easily to use by users. And also one huge pain point for many users is that how can we load data from remote data set to your local folder? And we are continuing improving our loading performance by dynamically allocating the loading job across multiple servers so we can load the data faster. In the Kubernetes world, if we want to change the configuration, we don't want to just shut down the whole cluster and then launch it again, which is pretty like we have some downtime. We don't want this to be happen. So we want to support updating the configuration during runtime. And also we have many of the FUSE enhancement like supporting the LibFuse 3, and we continue improving the FUSE performance by optimize the remote RPC. In every week on Monday, 6:30 p.m., we will have a Alluxio community sync. In this sync, contributors from different companies, and they will join our sync to contribute some of the FUSE improvements back. And also we will discuss about how can we improve this project, how can we improve the stability, improve the performance, and how can we move this project forward and let it be more mature. So join our community sync and we can create the solutions together. Okay, lastly, we are always hiring. We hire sales, we hire pre-sales support, all kinds of roles. So feel free to contact us if you have interest. And you can feel free to join our Alluxio community today. And we have the Slack channel that you can ask questions here and share thoughts about how to use Alluxio and how to develop Alluxio, so we can create the solutions together. Okay, I will hand this back to Jasmine for Q&A session. Hey, Jasmine.
Thank you, Lou, very much for the great presentation. So I've actually got here is Adit, our own product and product marketing manager, to help moderating this session. And then let's see if Adit's got some question for you.
Hi, Lou. Good morning. Thanks for the very insightful talk. I have a few questions on your talk. I saw that you mentioned that you've been using GPU instances with Alluxio and TensorFlow. Would you care to comment about your recommendation for splitting different resources such as CPU, memory, or any NVMe or SSD drives available on these instances between TensorFlow, the compute engine, and Alluxio?
Yeah, usually we run the training jobs on GPU instances, and especially for TensorFlow or PyTorch, they are pretty GPU intensive. So we want to we are not using, Alluxio is not using the GPU resources. We're mainly using the CPU resources and also some of the memory. So you need to maybe divide maybe 4 CPU or 8 CPU for Alluxio service and some part of the memory for Alluxio for it to run and fetching the data for you. But most of the GPU resources will be you'll be left to the TensorFlow job for it to run and do some of the image training or other things.
Got it. Thanks, Lou. Another question that I have is, you mentioned various different ways of deploying Alluxio and also TensorFlow. But you also mentioned things like Kubeflow, Arena, and Fluid. How does scheduling work in this environment, and what kind of data locality do we get for the TensorFlow jobs on Alluxio?
So when you're running a job for the things that I mentioned, like Kubeflow, like Arena, they are actually really helpful for us to run the distributed training job on a cluster. So you can have one command to launch the whole distributed training job. And by using Alluxio, we can expose the data to those training jobs via a local folder access. And Alluxio can help to catch the data in the whole cluster. So the data that is loaded into the Alluxio, it may be in your local machine or it may be just in your nearby machines. So it's much quicker than you go through the whole network and to fetch it from remote during your machine training, which may make your GPU instance idle, which is pretty expensive.
Got it. Thanks for that answer, Lou. One more question that I have is, you mentioned the use of a CSI driver, and you also mentioned that Microsoft is using path level configuration for different read and write cache types for the input and output folders. Do you care to elaborate on that for how that benefited their end-to-end workload?
Yeah, and usually Alluxio requires have different configuration optimization for read and write path. For example, in our read path, we assume that the data didn't change, and in this case, you can cache the metadata and data locally. So not only have Alluxio caching the data for you, but you can also cache the metadata that close to your local node, which means that this node in a single node, when it's running the training, it does not need to go to the Alluxio master to refetch the metadata. It can just catch the metadata locally to avoid some of the remote RPC overhead. So this is one more layer of optimization. But when users they want to make some modifications, they don't want to actually cache in the cluster. They might want to directly go to your UFS. And in this case, you can create a mount and configure it to be different write type. Either you want to write to Alluxio or you want to bypass Alluxio to directly modify your UFS. You can configure different configurations based on your use cases.
Got it. Lou, you mentioned a few exciting collaborations in the community at the moment. Which one are you most excited about?
That's a pretty interesting question. Yeah, and what I'm most interested about is actually people if we as a developer, we have our developer view of how things should work and how can we improve the project. But from the user mode, they have a user view of actually how we want this project to go. So sometimes if it is the same, but sometimes it's different. And when it is different, we really want to know, okay, oh, sometimes it surprised me that they have different opinions on this project and what's the direction they think that our project should focus on. Maybe it's the performance, or maybe it's the stability, or maybe some of the features that they want is not yet considered by us. So that's the part that I'm really interested about, and I'm really thankful for their views.
Words of wisdom, Lou. You're wise beyond your years. Thanks a lot, Lou, for that wonderful talk. Next, I would like to introduce our speaker from Intel, Ginger.
All right, thank you, Ajit. So, and thank you, Lou. Those are my dear friends as well. Looks like Lou handled it pretty well. So if you guys have any questions regarding, Alluxio handling machine learning and NI loads, as you could tell, Lou has been working on this project together with Ben for a while. Find them on Slack, or if you have any initiative that you're interested in regarding machine learning and AI workloads, that's where you would be able to get us. And then, or if you're currently working on Alluxio or deploying Alluxio and have not chat with me yet, or anyone on our team yet, like I said, if you have any other open source or collaborating with Alluxio that you would like to, showcase that your current work, we would love to feature you on Alluxio Day as well.